This video idea is thanks to Ken G, who passes along a question from another venue. Do all rocks start as quartz? Quartz and its polymorphs make up a huge swath of what people think of and look for when they talk about collecting minerals and going rock hounding. Silicon and oxygen are, after all, the two most common elements in Earth's crust. So maybe it shouldn't be surprising that someone asked the question. The answer is no, by the way. But the why is actually pretty interesting. For example, we could use it to springboard to what quartz and minerals are, and building on that, what rocks are and why some minerals form when others don't. Quartz is SiO2, or silicon dioxide, a compound so common and important that it's got a shorthand term, silica. It's good to know the difference between silica, silicon, and silicone. Anyway, only things that start as silica can start as quartz. Calcite can't start as quartz because it's calcium carbonate. No silica to speak of, or at least not in any major quantities. But what do I mean when I say start, anyway? We've got to get atomic and think about how minerals grow, because minerals form by the regular arrangement of atoms. For quartz, silicon bonds with oxygen in an arrangement most stable at its formation conditions. Although there's some variety of quartzes like high and low quartz, by and large, the reason quartz is so common is because it's stable at such a large range of pressures and temperatures. To get those silica molecules to pack together differently requires marginal cases of environmental conditions like ultra-high pressure to form coesite, which is still just silicon dioxide, but arranged in a different crystal system. Then if you start throwing more and more other elements in there like magnesium and iron, those elements also want to bond with oxygen, and they do so in a different configuration that leads to, say, feldspar or biotite. Now, that is, of course, a massive oversimplification, not least of which because a system can be multicrystalline. Minerals that form at similar conditions can grow simultaneously from the magma or water or whatever medium the elements are mobilized in. In a granite, a lot of the crystals of feldspar and quartz are interlocking because they were forming around the same time. However, the feldspar growing with quartz obviously didn't start as quartz. Building off of that, in some granites and in many other rocks, there's a definite order of crystallization that we see time and time again in the mineral-textural relationships. But if something like quartz and feldspar form together, how can we say that the granite didn't start as quartz? There's a very important relationship between minerals and temperature. Bowen's reaction series records the systematic relationship of mineralization of igneous bodies based on temperature and composition. Olivine, pyroxene, amphibole, biotite co-crystallizing with the feldspars, and then as the temperatures continue to drop and the system grows more felsic, we get the potassium feldspars, muscovite, and lastly, quartz. That ubiquitous silicate formed last in this long chain of minerals. These rocks are very, very far from starting as quartz.